Hello, my name is Connie Liu. I'm an undergraduate at MIT, and today we're going to be doing a few concept questions about mutation effects. So primarily, we're going to be identifying different types of mutations. So I'm going to give you a few examples of mutations that could occur, and you'll just name what type of mutation that is. So in the blue font, that's going to be the original DNA sequence. As you see, I arranged them in threes. So those are our pseudocodons, basically. And in the red, that's going to be the mutation that occurs. So you're just going to name what type of mutation it was. So let's start out with this first one. Take a look at it and try to come up with what type of mutation this is. So this one's going to be a point mutation. The reason you can come to this conclusion is because you're starting with the fat cat, and then this A becomes replaced by a C. So whenever you have something just being replaced like that, then it's going to be a point mutation because it's only affecting one point of your DNA sequence. So now let's move on to the next one. Give this one a little thought and then come up with an answer for this. Alright, so for this one, you could have said a few things, one of them being deletion. And a deletion is a type of frameshift mutation. So you could have also said frameshift. The reason you can identify this is if you go from this top original DNA sequence, you notice that this A is now missing. It reads the FT, which means that the A is gone, and that means it was deleted, hence why it's called a deletion. As you can see, it's also called a frameshift because this C suddenly moved over here, and then these codons all read different things now. What's really dangerous about frameshift mutations is it can cause a lot of amino acids to change down the line, and that means you're very likely to come out with non-functional proteins. On the contrary, if you look at point mutations, it's only affecting one of the amino acids going into the final protein, so it's usually likely that there's not too big of a final effect on it. So point mutations tend to be a little less detrimental. And this is the last sequence, so take a look at this one and let me know what it is. Alright, so for this sequence, if you go from the original to the mutation, you notice that a C was added to it, and that means it's an insertion. So the C was inserted into the DNA. And this one's also a frameshift. So the reason we know this is because this codon now reads something different, but also the next one, because this T got shifted up, and that means everything else has to be shifted up as well. And that's why it's going to be a shifted frame and can also have the same detrimental effects of changing a lot of amino acids down the road as we were discussing with the deletion mutation.